Viewers, there are some moments in history that are best described as epical. India's soft touchdown on the lunar South Pole will be one of those moments. Our scientists began only with their genius, as you can see in those pictures, and little more, in the most modest way imaginable. These are the photographs of Dr. APJ Abdul Kalam and R. Arvamudan, including, of course, Dr. Sarabhai, Vikram Sarabhai, after which the lander has been named. It's been a gigantic leap from those humble beginnings to the moment when Chandrayaan-2 lifted off on July 22nd. Today, just over 40 days later, India will become only the fourth nation to land on the moon. Vikram the lander and Pragyan will then etch into the lunar soil the Ashok Chakra that is imprinted upon the wheels of the rover. If ISRO discovers water as it expects to, there will be others who will race to the spot to set up bases. But remember, viewers, even if they get there before our astronauts, part of the Mangalyaan mission in 2022, they will find the Ashok Chakra imprinted, staking claim. Times now will, of course, be at hand to bring you the moment that will make history. But before we progress, let me give you a very quick overview of the mission and why it is epical, viewers. Why it is epical. Now, the first most important aspect is that it's the first mission to conduct a soft landing on Moon's South Polar region. At least the first Indian one. The first Indian expedition to land on the moon with indigenous technology, entirely indigenous. This is completely homemade. India to be only the fourth nation ever to soft land on the lunar surface, and if successful, ISRO to use the same rocket GSLV MK-IID for Gaganyaan. Viewers, the success of the mission in the wee hours will be defined by those terrifying 15 minutes, as K. Sivan, the chief of ISRO, has famously said. And we will bring you up to speed with what will happen in those 15 minutes. We are joined at the very beginning of this story by astrophysicist, author, science communicator, presenter of the world-famous TV show Cosmos that I grew up watching as a young boy and was once hosted by the legendary Carl Sagan. Today we have Neil Degrasse Tyson with us. It's such an honor to have you tonight with us. Mr. Tyson, as you look on and perhaps jog back your memory to the time when America landed Armstrong and others on the moon, 1969, you were 11 years old. And today India is perhaps going to get there. What does it mean for a nation to see a feat of these proportions?
Yeah, there's nothing like it in the world. It's almost as though it's a force of nature unto itself, where a nation comes together and a force of nature unto itself. A nation comes together and they become participants in a common goal that is a great achievement in civilization. In India, the world's largest democracy, this is an achievement of politics, of funding, of social will to make this happen, and to be a participant in the future of what our civilization will be bringing to us. I just want to congratulate everyone in India for being for contributing to this, because, as you say, it is completely indigenous technology, and that is itself yet another kind of achievement to be celebrated.
Well, India has distinguished itself recently by producing these marvels at very low cost. Mr. Tyson. I mean, it's the program that you are going to witness tonight has been put together with lesser budget than the Avengers movie budget. And that is a statistic that makes for fascinating reading. But what does it mean actually on the scale that we're witnessing here?
So space is expensive and it's hard. If you can do it for less, that opens up other opportunities, not only within your country, but for other countries looking over the fence saying, oh, is that how you can do that? Oh, I didn't know you could do it on the cheap that way. And then it becomes, you can set an entire movement into place where space becomes something that is not just what the rich in the richest countries can embark upon. It's something that can be part of everyone's dream, practically no matter what your economic circumstances are.
Now, there are many people who sometimes take on a preachy, critical, air about them, say that, well, why does a country like India need to focus so much on a space program? But we know, don't we, Mr. Tyson, how this opens the pathway to greater technological advancement. Can you talk a little bit about that? It's very important tonight.
Oh yes. So here's how that works, okay? So this mission is making headlines right now. And let's say I am a teacher or I'm a student and I'm reading those headlines and say, wow, I wonder how we did that. Let me investigate that. Oh, you had to learn science. You had to learn math. You needed engineering, especially engineering. And so you mentioned the scientists that were fundamental to this. There are surely thousands of engineers back there as well who participated. So you create a culture where these activities are valued. And out of that culture become other benefits to the nation. And because you create a situation where, oh, we can land on the moon, I know we can solve this other problem. And it's not just spin-offs. Yes, there will be spin-offs, spin-off technologies, where the lander promoted something else that came out, derived from it. Yes, but that's not the biggest effect. The biggest effect will be on your educational system, where people will say, I want to be a scientist too. I want to be an engineer too. And the future economic growth of any nation in the world is linked to innovations in science and technology. Without it, you are a spectator on everybody else who is investing that way.
Well, let's talk a little bit more about the mission at hand. Now, Chandrayaan-2 is aimed at sampling the water as well as other minerals, and will also open up the possibility of India sending astronauts to the moon. Now, how worthy a pursuit is that? America did it, through the early 70s and then suddenly and mysteriously stopped. Why did it do that? And now it wants to go back there again. So what are the advantages?
So just a brief bit of history, which is not widely appreciated even in the United States. When we went to the moon, most of us told ourselves, oh, we're going to the moon because we're explorers and we're Americans and that's what we do. But you part the curtains of that and you realize, wait a minute, we are in a Cold War with the Soviet Union and they're making advances in space. And that's embarrassing for us. Right? This is this huge communist country, and we feared them. So we said we must achieve in this way. So the motivation was entirely fear, from fear of the Soviet Union's powers. So then when we got to the moon and said, wait a minute, they're not coming, they're not there. So they're not coming right after us. So the motivation evaporated. And then we stopped going beyond Earth orbit altogether. And people said, oh, we lost the political will. No, behind it, there was no competitor anymore. The advantage to what you have done is, India, have done, is you have gone to the moon without a military motive. You're doing it because you know it's a good thing to do. You know it can stimulate interest in technologies and other pathways of human pursuit that will benefit India down the line. And again, I just congratulate you all for this achievement.
Well, let's talk a little bit about this curiosity that is building up about the moon. The Chinese got there. The Israelis had a sort of horrible, accident, mishap. They lost their craft, tragedy. 36% of these missions are successful. So you're really up against odds, aren't you? I mean, this is technologically very difficult. Can you take us through a little bit of that, astrophysicist as you are?
So for people to appreciate it, since there's no fuel on the moon, you have to bring all the fuel you will ever use with you and launch that from the pad. In some of your graphic videos there, you see the main rocket. It is India's most powerful rocket.
Yes.
Okay? So the rocket launches and it's burning fuel. It's got to leave Earth. Then typically what happens is it will go into low Earth orbit and get ready to send another branch of it towards the moon. And each time you do this, you're emptying fuel tanks and just discarding them because you don't want to carry this excess weight. So now you go to the moon, but you arrive at the moon with too much speed to do anything. So you want to slow down to get into orbit. That takes fuel as well. So a lot of the fuel you used launching from Earth was just to get the fuel you didn't use yet so that you can use it later near the moon. So now the orbiter goes in, it slows down to a speed that allows it to achieve lunar orbit. Then you say, okay, now we deploy the lander. Okay, that's the most important thing of the mission because it's got the rover. And so that's got to land softly. When you land on a planet or an object that has an atmosphere, you use the atmosphere to slow yourself down.
Yes.
Okay, it's basically aerobraking. Moon has no atmosphere. So you need fuel to slow down so that you don't crash on the surface of the moon. All of this ballet, this space ballet, has to be done with high precision. Otherwise, you can miss lunar orbit when you get there. The deployed lander could go into the wrong place. It could have the wrong speed. All of this has to work. And that's why space is hard, and it takes smart people, it takes scientists, and you've got them, and you have them on this mission. Now, if I can add why the South Pole is interesting.
Yes.
Unless you already had that planned in your program.
Well, I was going to ask you that question, so it's great if you can answer it.
Yes, okay. So we've all grew up being told there's no water on the moon. It's a desolate, dry place. That's basically true, except near the poles. Now here's what's interesting. When you're near the poles, there are craters, but when you're near the poles, the sun never gets very high above the horizon. That's true on Earth as well, okay? So it turns out there are craters where the crater walls prevent sunlight from ever hitting the bottom of the crater.
Right.
So that when the moon has been hit in the past, and you know it's been hit in the past, just take a look at how many craters it has. If it's been hit by a comet, which is mostly water, and many asteroids have water, are rich in water as well, the water would, so on impact, all of that evaporates. But then the water molecules land again. If they land in the bottom of a dark crater that never sees sunlight, it's called, it's a trap. It's a water trap. That water that hits in the bottom of the crater will never evaporate out again, and it will slowly accumulate. And so we have high hopes, as you announced at the beginning, that if we find these places that have water, that can target future places to land astronauts, so the astronauts don't have to bring water with them. It's on-site use of resources, and that's really how you sustain an active future of space exploration.
In what state is the water going to be? Is it going to be in crystal? I mean, explain that.
That's a great question. Can they go ice skating when they get there? So no, it's not clear. Some satellite measurements, radar measurements, indicate that there's water there, but it's not likely in any kind of reservoir. All right. What you might need is some kind of apparatus that can sift through the lunar. It's called the regolith, which is the lunar soils. Sift through it and extract from it the water molecules, and then you out the other side of that machine, you get your cup of water. So no, it's not just a lake or even a deposit. It's going to be mixed in. Remember, we're talking about water molecules here, not just buckets of water that you can just haul back into your spacecraft. So it'll take another level of engineering and design to make that happen. And by the way, something I missed. The space is not just aerospace engineering. If you're going to send astronauts, their health matters in space. So you need doctors, medical doctors thinking about this sort of thing. They're going to have to eat food over long periods of time. You're going to need nutritionists. You're going to need machines on the moon to get stuff done. So you'll have factories making things that had nothing to do with the rocket itself. So it percolates through the entire society. And I remember, that's how old I am, in the 1960s, everybody embraced science. And because the headlines were written every single day. Right now, I think here in America, we kind of taken it for granted. We say, oh, science, do we really need science? Meanwhile, you're using your smartphone to say that. So that's why the South Pole and the North Pole have this kind of interest.
Right. So I wanted to ask you this. Spectrometers exist. We've got great satellites now with these spectrometers, and they should be able to detect the composition of soil, how much perhaps water is in there. Why do we need to land Pragyan, our rover? Why would we need to do that?
That's an important and very good question, but let me take you back 30,000 years. All right. So let's say you're in the cave, and we're all there in the cave, and we look out in the cave, and we can see a mountain. Are you the person in the cave who's saying, no, we shouldn't visit the mountain because we can see it? Are you the one who says, let's not go to the mountain, we have problems in the cave, let's solve the cave problems first, before anybody leaves the cave and goes to the valley and the mountain? Are you going to be that person? Were you that person 30,000 years ago? And whoever were those people who influenced their cave, they got nowhere. They died in the cave. It's the people that went out and explored and found things they weren't even looking for. And you go out through the valley, there's other food sources, there's streams, rivers, mountains, other animals. There's horizons you never imagined. That's what exploration is. And when it's in your soul, when it's in your soul of curiosity, discoveries await you, and the future of civilization awaits you as well.
Well, those are beautiful sentiments, beautiful sentiments. Now, India is planning, depending on the success of this mission, to take men to the moon in 2022. That's when India turns 75. Now, there's a lot of training that goes into that too, and that's been our best pilots are undergoing that training. The leap from here to landing a man on the moon or a couple, is that very big, or is it just the next logical extension?
You're going to need a bigger rocket, to quote a famous line in a movie. So the rockets are sized for how big the payload is.
Right.
So your payload now is a lander. Well, your payload is an orbiter and a lander and a rover. So if in the future, and 2022 is not far away, you want to put people have much more weight than what you're sending up now. And there's life support that those people need. The thing about robots are, you don't really have to feed them. You give them a little sunlight every now and then, maybe. And plus, they don't complain if you don't want to bring them home, right? So robots have certain advantages over people, but if you send people, I don't know any time where anyone has given a parade for a robot, but you get parades for people. So a human being who can come home and tell the story and visit the schools and be the tangible expression of exploration, that has value beyond the cost that could ever be laid out for this. So it's the same mathematics to leave Earth, go to the moon, orbit the moon, drop a lander. but it's a much bigger rocket because now your rocket has to carry the fuel needed to get back to Earth. Okay? So all of this goes up exponentially. And so that's another challenge, but engineers love challenges. That's what they want. That's all they want. So if you have good engineers, it's just the next problem on their desk.
Okay, you mentioned mathematics. Now, what are the odds of India being able to achieve that target in just about 3 years, provided this goes?
I'm not close to what your state of rocket engineering is at this moment, but I can tell you that, by the way, another way to design rockets is you have a main rocket and then you have these boosters that you attach. You remember in the 60s, we had this one big Saturn V rocket.
That's true.
Okay, and all the fuel was in that. And it later designs, SpaceX among them, you have a main central rocket, but you attach boosters.
Yeah.
And so you can imagine a future where your destination, you say, I want to go to Mars today. Okay, here's the base rocket. Now put in some extra boosters.
Yeah.
And you sort of staple them on, and then that gets you the extra power you need. That would be turning sort of a one-off space shot into a space industry. Then it becomes part of your daily life as Indians. And so that's a way to think about how you might take this into the future. But right now, I couldn't answer for you if 3 years is realistically ambitious, or right there, or impossible. I couldn't tell you. So it's never impossible. By the way, it's just a matter of money and time are correlated here.
Yeah, that's true. That is true.
So if you have enough money, it'll cost you more to do it quicker. If you don't have the money, it takes a little longer. That's fine too.
Well, that's what we have to start thinking about back here in India, because amongst the BRIC countries, the 5 BRIC countries, India spends the least, viewers, and this is something that you must know, least on R&D. So we really need to up that component. And for our scientists, this is an opportunity to prove that they're ready, actually, to tell the government that you now need to back us. Neil Tyson, a couple of more questions. Look, big fan. I've watched your shows. I watched Carl Sagan growing up. I just want to ask you this. There are many, many millions, and we have no shortage of people here, right? Millions of children today, millions of young people today going through, high school and then college who are going to tune in. And how inspiring is it? Because there's a touching story between you and Carl Sagan, and you referred to that in the series. How inspirational is this moment?
So the way I think about it is everybody in the United States, perhaps even the world, remembers where they were when they saw Neil Armstrong step down on the moon. It's just, you didn't have to try to remember that.
Yeah.
It just is there. And so your coverage and the achievement that this represents for India as a nation that, as you said, is behind really in research and development spending. And that also means you'll be a little lagging in what comes out the other side of R&D, right? That's where the foresight comes from. You can say, well, R&D, I can't afford that. I want to make this thing that I'm selling today, so I don't want to do any R&D. The R&D is the future. And without it, just move back to the cave, because that's where you'll end up anyway if you don't value the R&D. So all the school children, and I'm sure this is being broadcast or they're on the computers all over the country, everyone is going to remember this. And that memory fuels ambitions in ways that nothing else does. And I used to think I was biased, to think, well, I happen to love the universe. Is it only inspiring to me? No, it's inspiring to everybody, because everybody looks up. They're going to be able to look up tonight and see the moon and say, we have a spacecraft there. And if you can point to it, and parents will show their kids. And so this will be a remembered moment. And all of your intro to this broadcast, I think was spot on. Your enthusiasm and the fact that you're making history.
Last question. Giant leap for mankind, said Mr. Armstrong when he landed on the moon. Now, we've kind of lost our way. mankind has got very conservative, doesn't want to spend that much money. How far should we be pushing the boundaries? I mean, we know there's Elon Musk who wants to land on Mars in a couple of years, wants to terraform Mars and turn it into a living, breathing planet. How far should we be pushing this?
Why? That's not even the right question.
Okay.
How far implies that, oh, there's a limit and don't go beyond that limit. There's what do you, what? We are here on this speck, in this mote of dust called Earth. And we're saying, oh, don't go too far. No, by the way, it's also dangerous. Some people might even die. Do you know, we had several disasters here in the United States.
True.
Okay? Two shuttle disasters in space.
We lost an Indian American, a great pilot, great astronaut, Kalpana Chawla. She died in 2004. Yeah. Yes. So you can say to yourself, okay, stop the carnage, stop the risk. When you go to the families of those loved ones who died, that the family of the astronauts, and say, should we continue this adventure? To a person, they said, yes, we don't want them to have died in vain. Yes, this is exploration. Yes, humans have been doing this ever since we left the cave. Yes, are you going to be a bystander, or are you going to be a participant, or are you going to lead that edge? And when you lead the edge, you discover things that people never even dreamt of. And everyone then turns to you. That's a privileged place, but it takes wise governance. It takes an enlightened population. In a democracy, your population has to agree with this. And you have a lot of poverty in India. So you can say, well, should we solve the poverty instead of fixing space? Well, that's the cave problem. Are you going to tell me, well, let's take this money and it's going to solve all the poverty right now? No, that's not how that works. And in a democracy, you have a pot of money that you allocate. This goes to art, this goes to R&D, this goes to health, and it's that portfolio that is the identity of your country. And some of that portfolio had better be somebody thinking about the future. Otherwise, you will never solve the problems that pervade. Neil Tyson, wonderful speaking to you. Hopefully, you'll be coming out with another series of the Cosmos, and we would love to watch it. Take us into the future. Thank you very much. Thank you very much.
Excellent.
Thank you.
And
great talking to you. Well, viewers, it's very important to know 15 minutes is what it's all going to come down